Heat capacity and specific heat capacity. I am going to distinguish the two, both in words and mathematically. We are going to first of all understand that capacity means ability. Heat capacity is the ability of a given mass of a substance to absorb heat. It is the amount of heat per degree rise in temperature that any mass of a substance can absorb. Just begin to heat a substance until it experiences a degree rise in temperature. This particular heat that is required to raise a temperature of a system by 1 degree is what is called heat capacity. So heat capacity is the ratio of this particular quantity of heat to the change in temperature, which is change in T. Therefore, heat capacity, capital C, is equal to Q divided by change in T. Specific heat capacity. This is the heat capacity that is specifically for 1 unit mass of the system. It is the quantity of heat used to cause a degree rise in temperature of a unit mass. Specific heat capacity is equal to the quantity of heat divided by mass of the substance times degree rise in temperature. In thermodynamics, we are talking about a system and how it absorbs heat or how it releases heat. Therefore, we are going to derive the formula for this quantity of heat. From here, you can clear the fraction by saying Q equals C dt. And here, Q equals this times this, which is M C dt. Is there any mathematical connection between heat capacity and specific heat capacity? Let us find out. Let's check this equation out. Heat capacity is equal to quantity of heat divided by change in temperature. Let's call it equation 1. Let's call this equation 2. If you are taking the equation connected to heat capacity, this, you will look at this Q and change it with Q in specific heat capacity. If you are taking this equation for specific heat capacity, you will change this Q. You will replace this Q with the Q in heat capacity. Now let's go. So this is the equation. Small c equals quantity of heat divided by m dt. This is the equation 2 itself. So what we do is to change this Q with the Q in heat capacity. That is this. The Q here now is capital C dt. So we do that. C equals capital C dt divided by m dt. You can see that dt is up and down. You cancel them out. And small c is going to give us capital C divided by mass. Therefore, you can clear the fraction by saying capital C equals small c times the mass. And this is the relationship between heat capacity and specific heat capacity. So, the heat capacity can now be given a mathematical baptismal name from this relation. We can now say that heat capacity is the product of specific heat capacity and the mass of the system. From here, you can also define specific heat capacity as the ratio of heat capacity to the mass of the system. So these two equations are very important in thermodynamics. I hope you got value in this video. If you did, please share it so that students and teachers that may need it for their instruction will get to see it. Do have a wonderful day. Bye.